Yes, you know I got you. I got you. So as you guys can see, it is going live now, and I need to change my background because that's not what I'm going to do. Okay, so let me go ahead and change my background. As you all can see here, I am live on YouTube, and it is muted for that reason. Well, on my end, so that way I can hear and not get feedback. But let me change my background because we're not talking about makeup right now and skincare. Okay, I forgot this was on. So let me choose a different background. The chemistry background. Yep, there we go. All right, guys, y'all ready to learn? Now, IMEX Web, what are you talking about? What are you referencing? So, as we get started, guys, I just want to tell y'all my voice is a little raspy because I've been doing so much talking, and as a result of that, and it could be a combination of pollen, who knows? But I got my tea on deck, okay? I had to make me a big bottle of tea. I got some cinnamon tea with ginger and lemons all mixed together. Okay, you're talking about going back to college? Okay. Well, and you know what? One Max Web, you can always do a community college. That's where you save those coins, save that money. So what I'm going to do today is kind of go over some things with you guys. And I'm excited about today's lesson because some of you all have been asking me about it. And so I want to make sure that you all get what you need from this information, okay? So let me make sure, hold on. Okay, there we go. So I want to make sure that I am presenting this information in the right way for you guys. Now, you're going to see my stuff up here, because I am live on IG. Yes, 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 yes. I'm gonna tell you right now, school can be very stressful. It can be, and I trust me, I know I get it. And that's why so many people are fighting now to to make sure that we can get these student loans passed where they are forgiven. Because I know so many students that took out student loans do need extra, I would say, extra grace in the process. You're welcome. So, for those of you all that are new to me, my name is Professor TK the Chemist, and I teach college chemistry students and high school students chemistry in a fun and engaging way. So many of you guys may be on the struggle bus with chemistry and you're trying to get help and you just don't know where to go. Well, guess what? Professor TK the Chemist is in the building, and I give free tutoring Monday through Thursday, 12 noon Eastern Standard Time. So for those of you guys that need extra help in your chemistry classes, this is for you. I know that many students are going to be taking their exams the first week in May, and you are anxious to get it out the way, but you want to make sure that you're going to stay on top. So continue to come to my sessions every week, Monday, Tuesday, Wednesday, Thursday, so that you guys can get what you need out of these free tutoring sessions, okay? Now, I try to answer everybody's question, but sometimes it's so difficult to do so because there are so many requests that I get on a daily basis from the DMs to your emails. So I try to answer them, but if I can't, please don't hold that to me, okay? Don't charge that to my heart, okay? If you need more individualized attention, please, by all means, come and tap that link in my bio and you can get tutoring that way if you need more one-on-one tutoring. Okay, so for those of you all that would like to get a copy of this video, you can always go back to my YouTube channel and you can have access to that. Because let me say this too, okay? What I've been doing is I've been downloading the videos on my site, and then I have to edit them out for conversations like this. So whenever I'm talking, y'all don't want to hear all this on the YouTube channel. It's like you want to scoop, 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 scoop. So because of that, you're going to get things like this, where it's me talking, okay? But if you don't want all this in it, you have to wait for me to download it, and then I have to edit it. And like I've said before, editing takes a long time to do, but I'm getting it done, okay? So I'm going to go ahead and get started with my lesson now. I just want you guys to know that this lesson is going to be great on oxidation and reduction. Now, we did introduce this to you guys yesterday, so let me go ahead and show you all what we're talking about here as it relates to oxidation and reduction. Now, for this next section right here, I told you guys yesterday, oil rigs. That's the acronym for oxidation is loss, reduction is gain. And what that means is you have to know the difference between an anode and a cathode when it comes to writing out these chemical reactions. I will also put that on the screen when I flip it back to the next page, okay? Something else you want to remember is electronegativity increases as you go across a period and decreases down a group. That helps you know whether or not the element within that compound will have a positive or negative oxidation number. Now, there are some exceptions to those rules, and I would request that or require or make a notation that you would want to have your periodic table nearby and some of those, maybe the electronegativity chart, okay? Now, these are the steps that we're going to actually go through today as it relates to, and I wish I could move this out the way, y'all, but I can't. But what I wanted to also tell you guys too and mention to you is that when you are using problems doing of this nature, half reaction, oxidation, reduction problems, there are several steps you're going to have to know, okay? Several steps. Step one, you're going to have to write the oxidation and reduction half reactions, and you're going to balance atoms other than oxygen and hydrogen. So that is step number one right there. Let me zoom in so you can see that. That's step number one. Step number two, you're going to balance each reaction for mass and charge. So that means you're going to balance oxygen atoms by adding water to it. Step number three, you're going to multiply those half reactions by appropriate coefficients so that the electrons gained and lost are equal. That means you're going to balance hydrogen atoms by adding hydrogen plus when you're dealing with acidic solutions, or you're going to add hydroxide ions when you're dealing with basic solutions. And again, I will tell you which type of solution we're working with so you'll know which one to do that for. And then lastly, you're going to add the half reactions together and simplify to get the overall balanced equations. You're going to balance the charge by adding electrons, okay? So those are your steps right there that you'll need to know as it relates to these types of chemical reactions, okay? So now let me go ahead and go to my next screen here that you guys are going to actually pick up on as we discuss these types of chemical reactions, okay? So I'm all about the color coding. As many of you all that may be new to me, you're going to find that I use a lot of different colors on my lessons here because I want to make sure that you all can kind of pick up what I'm putting down, because I know a lot of times when you see everything just in black and white, sometimes it doesn't make sense. So you got to have some color, okay? You got to have some color. Now, speaking of color, here it is again. These are the rules of engagement. So let me zoom in again so you all can see that, okay? Now, remember, I just said oil rig, right? Oil rig, okay? So let me go ahead and show you all what we mean by that. Oil rig, oxidation, okay, is losing, and reduction is gaining, okay? Oil rig. Now, because oxidation is losing electrons, that means that's going to be considered your anode, okay? So I'm going to put this here. I'm going to put the oil beside anode. An anode is when the oxidation loses electrons, as we just said, okay? losing those electrons when those electrons occur. Now, because that's oxidation, okay, anoid, keep that in mind when we do these problems. Okay, keep that in mind when we do the problems. Now, rig, that's for the cathode. The cathode is when you're doing a reduction, meaning you are gaining electrons, okay? So reduction is gaining electrons. And yes, Shohab, an ox and red cat. Yep. Oxidation, anoid, red cat, reduction, cathode. Yes, 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 yes. An ox and red cat. Yes. That can help you remember these types of problems. Now, I always like to start off with the basis. Yes, that is correct for galvanic reactions. And that's pretty much what we're going to be dealing with today. Now, as you take a look at the periodic table, okay, I'm going to be asking you different questions about these elements. As I said before, as you go from the left to the right, okay, from the left to the right across your periodic table, the electronegativity increases. And I know that fluorine is the most electronegative element. As you go from the bottom to the top, they also increase, okay, as you go from the bottom to the top. But there are some exceptions to those rules. And we talked about that yesterday in terms of what they are, like copper and gold. They're in the same group, but at the same time, you would think that copper would be the most electronegative, but in this case, it's actually gold, okay? So what I'm going to show you all are some examples here. We're going to start off with the basics in terms of knowing how to balance half reactions with these oxidation reduction processes, okay? So just walk with me and be patient as I explain all of these different steps, okay? Now, right here, you have aluminum, solid aluminum, reacting with copper, aqueous copper, to give you copper and aluminum with a 3+ charge. I want you guys to notice those charges. So we're going to write down the first one. We have aluminum. Okay, that's solid. That goes over to aluminum with the 3+ charge. Okay, and again, we know that that's aqueous. Now, because we see that right there, what we need to do also is balance this out by writing 3 electrons. Now, because I wrote it out in this way, because aluminum started off being just regular aluminum, and then it yielded the aluminum ion charge in that manner, we know that that is the oxidizer. Okay, this is oxidation right here for that one. Okay, keep that in mind. Keep that in mind. And also, what we know is that this one is an example of being the anode, if you want to think of it that way too, okay? If you want to keep, oops, sorry, you can't see that part, I'm sorry. Let me scoot out a little bit. That's the anode also, if you want to think of it that way, okay? That part is not really necessary for what we're doing, but just in case you guys still want to keep up with that process. Now for copper, copper has a 2+ charge, okay, and it's aqueous also, and we're going to put the 2 electrons there. And we know by writing it in this manner, in this step, this is reduction, okay? That is the one that is being reduced. Now, as a result, what we're going to have to do is balance these equations out, okay? So if you recall from the previous slide that I showed you, in step 3, we're going to have to balance out our electrons, okay? So that means this is step 1 right here. What I just did, I wrote them out. So I actually combined step 1 and step 2 by writing them out in their oxidation reduction process, okay? Now here comes the next step, and we'll just call this step 3, where we're going to have to balance out our electrons, okay? So what we're going to do, we're going to actually write out this formula again, but we're going to put the 2 around it, okay? So watch what I mean by that. All right, so I'm going to rewrite the top equation. And I'm going to write the bottom one. Okay. So when it comes to balancing them out, okay, notice that there's a 3 and a 2. So to balance this out, okay, for this one right here, this is neither, Jessica. This is just a basic half reaction equation, okay? This is just a basic half reaction equation. We're going to actually get to the acid solution momentarily. Now, what we're going to have to do here, we're going to actually multiply, okay, both reactions, all right, by their respective coefficients. So in other words, I'm going to put a 2 right here for this one, okay? And for the other one, I'm going to put a 3 because we have to balance out those electrons, okay? We got to balance out those electrons, and this is what we're going to end up with when we do it this way. Okay, so when we multiply the 2, okay, the 2 times the aluminum up there, we're going to end up with 2 aluminum, okay, solids, producing your 2 aluminum with the 3 plus charge plus 6 electrons. And then on the bottom one for copper, we're going to have 3 copper with the 2 plus charge, aqueous, plus 6 electrons, producing 3 coppers, solids, okay? So far, so good. Now, when we take a look at what we've got here, the next thing we're going to have to do is cross out those electrons because we don't need them anymore, okay? We're going to cross out the electrons because, again, what we were trying to do is balance this out with those electrons, and our final formula is going to be written as 2 aluminums, okay, solids, plus 3 copper with the 2 plus charge, aqueous, producing 2 aluminum, 3 plus, and that was aqueous. I left that off at the top, but I'm writing it right now, plus 3 coppers with the solid. Now, you're probably wondering, why are we doing this? Guys, this is similar to what we did yesterday, or actually last week when we were talking about net ionic equations. This is similar. This is like the same process. And this is why I was saying previously that if you know what you're working with, doing half reduction or half reaction processes are quite simple if you've done net ionic equations. It's all in the same breath. They're all in the same manner. Now, what you're going to do is do another example. See how easy this one was? Okay. All we did, let me go back through it again. Okay, I'll break it down for you, Alan. Yes, I'm going to go back through it again. Aluminum plus copper 2 plus gives you copper plus aluminum 3 plus. And what we did was we wrote out which one was the oxidizer and which one was the reducer, okay, the reduction. Then in the next step, we're going to figure out how many electrons we can balance out for both of these. The top one had 3 electrons. The bottom one for copper had 2. The common multiple is 6. But in order to figure that out, you've got to multiply the top one by 2 and the bottom one by 3. So this gives us 2 aluminum with a 3 plus charge, plus 6 electrons. And for the second equation, 3 coppers plus 6 electrons and 3 copper solids. Okay? And then all we have to do now is cross out our like terms in terms of those electrons because we no longer need them. And we cross them out. And now we end up with writing down what's left over. 2 aluminum plus 3 coppers with the 2 plus charge, producing 2 aluminums with the 3 plus charge plus 3 coppers. And that's your final reaction right there. So, Alan, whenever you write out your reactions, I hope this answers your question. When you write it out this way, like the top row, the one that I have in purple right here, you are writing the solid form. You don't break that apart. It's when you go to the right-hand side that you write out what those charges are. Same thing for copper. We start off with copper with the 2+ charge, but we have to balance it out with 2 electrons, and then you have copper left over. So you're showing either the removal or the addition of those electrons. Thank you, Maria. So again, this is just another example of half reactions, okay? Half reaction. Now, suppose we're doing one. Yes, thank you, Micah. Yes. Thank you, Dreva. Oh, Claire. Well, I know you did well, so we're going to claim it, okay? We're going to claim it. Now, what I need to show you guys, okay, again, because like I said before, this is kind of a refresher on net ionic equations because it comes through on what we're doing here now. Oh, thank you, JXZY. Thank you. Dreva, did you not attempt any question? I mean, I'm just asking, I'm just saying. Now, let me show you. Oh, thank you, Marguerite. Thank you so much. Well, how can you get a 0? I'm not understanding that. Listen, okay, listen. This is where the tutoring center comes into place. Okay, you got to reach out for help. Because let me tell you, your professors at the end of the semester is not the time to be asking them, can you help me out in terms of extra credit? And can you hook a sister up? Can you hook a brother up? Because your professors are going to say, you had 16 weeks to come into my office to get some help. Okay, well, Dreva, can you DM me what your questions were? Maybe I can help you kind of undo that. Okay. All right. So for this next question, so someone asks, is this an acid solution or basic solution? So now we're actually getting into that particular problem, okay? So with this next one, you've got 10 with a 2+ charge aqueous that produces 10 with a 4+ charge aqueous. Now, here is the deal. Whenever you have acidic solutions like this one, okay? Oh, congratulations. I know about my area. You go ahead, sister. You go ahead. Oh, yes. Yes, 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 yes. I'm so sorry that y'all are saying that y'all did not do well. But look, one exam grade should not break y'all. Okay, I'm just saying. Whenever you have a question like this where it deals with acidic solutions, for this next one, you have to do the following. The side with the higher value should be decreased to look like the smaller number, okay? So in other words, you have this 10-2 with the +2 charge on the left. You've got 10 with the 4+ charge on the right. The side with the higher value should be decreased to look like the smaller number side. So that means I'm going to just simply write 10 with the 2+ charge, aqueous, and I'm going to draw my yield sign. Now check this out. Because the larger side is bigger, okay, and we want it to look like the smaller side, what we're going to have to do is reduce this by adding 2 electrons, and it's more like you're subtracting them. You know, chemists make things a little difficult. Juliana, you're going to do well. You're going to do well. Don't be scared. Go in there and knock it out the box. And then come back and report to me on Monday and let me know how you did. Thank you, OMO. So because you're writing it out in this way, guys, this is oxidation, okay? Because you are losing electrons, okay? So this is oxidation because you are losing electrons. So again, the rule is the side with the higher value should be decreased to look like the side with the smaller number. So in this particular case, we want to make sure that we make the bigger side, and let me actually color that one a different color so that way you all can see what I'm talking about. We want to make the pink side look like the yellow side, okay? So, Alan, when it comes to chemistry, I know, honey, it sounds so ridiculous, right? Oxidation means when you have that +2 charge right there, you're actually losing those electrons. So in chemistry, just a little quick side note, whenever the charge is positive, okay, whenever you have a positive charge, those are known as cations. And that means you are losing electrons. But when you have a negative charge, those are called anions, and that means you are reducing or losing or gaining, excuse me, you're gaining, okay, those electrons. So I know in chemistry, we make things so difficult. But yes, Juliana, thank you. We're going to say this over and over and over. Oxidation is losing, reduction is gaining, oil rig. And Alexis says, I think of it as it's low to high charge, it's an oxidation. Yes, you can think of it that way as well. Yes. Now, make sure y'all continue to tap that screen. Tap that screen. Because we need to let more people know, that Professor TK the Chemist is giving away free tutoring lessons every week, Monday through Thursday at 12 noon Eastern Standard Time. Yes, we got to get them likes up, y'all. I'm giving away free tutoring. I don't ask y'all for nothing but to tap that screen. That's all. That's all. And look, tell a friend to tell a friend to tell a friend. Share this out. Share this live with other friends you think could benefit from this. Y'all, I'm trying to get on that STEM talk. I'm trying to get on your FYP page. I'm trying to get on everybody's FYP page, okay? And look, I've been teaching for over 25 years, okay? I'm not new to this. I'm true to this. So y'all got to tell your other friends too, if they need some help, to come on over to Professor TK the Chemist page. And if you have friends that are also taking this during the summertime, because, they withdrew this past semester, tell them to reach out to me during the summertime, because chemistry during the summer is going to be, woo! Oh, yes. Well, and you know what? I know sometimes things come at the last minute. A lot of you all did not find out about me until later. We're gonna blame that on the algorithm. Okay. Kim says, I actually love chemistry, but it's so confusing. Yes, I know. I know. Now, excuse me, guys, on this next one, because this is it right here. That's all we need to do with that one, okay? We didn't have to do anything extra to that particular problem. Let's do one where you have, let me see, I don't think I finished this problem out either. Let me see, because I was typing and then I stopped. So that second one is probably wrong. I'm almost certain that second problem was written out wrong because I didn't finish it. So don't y'all hold me to that one. Yes, yay, Janie, yes. This one, y'all, yes, I was typing. This next one that we're going to do, yeah, like I said, I did not finish it out. This is MN. Ooh, people be just tripping for real, y'all. So right here on this next one, we've got manganese, okay? And it's this one right here. I'm actually rewriting it out because like I said, I was typing and I didn't finish it out. When you copy and paste and then you go on to something else and you forget. Yeah, I had to come back. So YouTube, this is the correct formation for this one, okay? Now, you've got manganese with the 2+ charge that forms MnO4. Notice that there's an oxygen there, okay? Notice that there's an oxygen there. So we need to figure out what we're going to do to get rid of that, okay? Yes, so Ray, I've done thermal chemistry. That's on my YouTube page and also on my TikTok page. So make sure you go get that. Yes, I can tutor you for the MCAT. Just hit that link in my bio. Yep, hit that link in my bio. Now, here's the deal when it comes to this example here with the manganese, okay? For manganese, you've got to figure out. Yes, I'm doing that now, Lenny. I'm doing that now. Can you explain the difference when doing basic versus acidic half reactions? Right now, what we're doing, we are doing the ones with acidic solutions. So for manganese, the side that lacks the oxygen, you must add water to it. Then you would need to add hydrogens to the other side to balance it out, okay? So again, the side that lacks oxygen, so let's highlight them so that way we'll know what we're talking about right here, okay? The side that lacks oxygen is the side that's pink. That one lacks oxygen. So guess what we're going to have to do? We're going to have to add water to that side. So I'm going to rewrite this equation, okay? I'm going to rewrite it. I'm going to say Mn with the 2+ charge, Aq, plus water, H2O, okay? And of course, that's liquid, yields. We're going to rewrite MnO4 with a negative charge, of course. Okay? But remember what I just said. The side that needs to balance the hydrogens, we're going to add hydrogen to it. Okay? So the pink side, we had to add water to it. And on the other side, okay, over here on the right side, we're going to add hydrogen to it, okay? So watch what happens when I add the hydrogen to it. I'm going to put the H+ right there. Now, what we need to do is we got to figure out how to balance this, okay? We're going to have to balance this out, and we're going to have to balance it out by balancing the oxygens. So if you notice on this side, on the right-hand side, we had 4 oxygens right here. So you know what we're going to have to do? We're going to have to put a 4 in front of this formula right here. So I put the 4 right there in front of H2O. Now, you know what that did? That gave me 8 hydrogens. So as a result of getting 8 hydrogens, I'm going to have to put an 8 in front of this one on the right-hand side. So that's where my 8 hydrogens comes from right there. But we're not done, because you know what else we have to do now? We've got to balance the charge by adding 5 electrons to the side of manganese, okay? So remember that manganese over there has a 2+ charge, right? Let me point it out to you. This manganese right here has a 2+ charge. We've got to balance it out in order to account for that oxidation state. That's going from 2 to 7, okay? From 2 to 7. So what we're going to have to do is add 5 electrons to this side. Now, again, if you forgot how to do oxidation numbers, we spent an entire lesson on that yesterday. We know that when the formula is written like this, MnO4 with a negative charge, we know that the ionic charge or the oxidation number for manganese in this case is 7. Well, 7 minus 2 gives us this 5 right here. Okay? Gives us this 5 right here. So now, all you have to do in this particular case is simply say, excuse me, and I'm just going to rewrite everything out in a cleaner version, okay? Manganese is oxidized to MnO4 with a negative charge in an acidic medium, okay? Or in an acid solution. or acidic solution. So a cleaner version of this formula here, or this reaction, is Mn with a 2+ charge plus your 4 H2Os, okay? Producing MnO4 with the negative charge plus 8 hydrogens plus your 5 electrons. Now, one thing I want to point out to you all also with this, put those physical states in, because your professors may be on that energy of saying, hey, you didn't put your physical states, so I'm going to mark it wrong. I'm going to give you half credit. So make sure you put your physical states in there, okay? So here are your physical states. Manganese was aqueous, liquid for water. Again, aqueous for that one. All right, and now this one, and now we are done, okay? Now, let's do another one, because sometimes you don't always get it the first time when you see it done, okay? So let's do another one. Again, this one is in acidic solution, okay? This one is in an acidic solution. All right? Excuse me, guys. Let me get a sip of my tea. Like I said, my voice is very raspy. Okay, excuse me. Now, again, this next one, this is still in acidic solution, okay? I'm writing it out so that way you guys will know. Thank you guys so much for the shares and the follows. I appreciate that. Thank you guys so much. You have iodate, that's IO3 with a -1 charge, aqueous, producing iodine in a solid form, okay? So what do you have to do? Well, first off, if this is all that you have, you're going to have to balance out the side that doesn't have oxygen. And you know the side that doesn't have oxygen is this side right here, okay? So the one that I highlighted in yellow, that does not have oxygen attached to it. So we're going to have to balance that out. Excuse me. So how are we going to do that? Let me go ahead and write IO3 with a negative, okay, aqueous. I'm going to leave some space because we're going to have to write something else out also. If we go back up here to this previous question that we did a second ago, okay, remember how I said, if it's not balanced, the side that's not balanced, you've got to add oxygen or water, excuse me. You have to add water to it, okay? So that's what we're going to do for this one. Same thing. The side that I just highlighted, we're going to have to add water to it, okay? So I'm going to put the yield sign right here so y'all can see that, okay? Because we're going to come back and fill in this side right here. We're going to come back and fill in this. But right now, we're going to go ahead and do the iodine side. So we have I2, okay, plus. Now we need to add water to it. That's H2O. Now check this out. The oxygen on this left side we had was 3. So you know what we're going to have to do? We're going to have to put a 3 right there in front of H2O. And so in doing that, that now tells us we need to add 6 hydrogens to the left side to balance that side out. Now, we're not done because we also have to include those electrons. And if you recall, the electron value that we needed, okay, if you think about iodate, okay, so IO3, let me go ahead and break this down for you. Iodine, all right, we don't know the initial charge for iodine. What we know is that oxygen has a charge of -2. So what we're going to do to find the charge that we know for iodine, we're going to say X plus 3 times -2, and that's equal to -1. So you end up with X minus 6 equals -1, and we're going to add 6 to both sides. X is equal to a +5, Well, guess what that positive 5 is going to do? We're going to add that to our equation right there. You see that? We added the positive 5 right there to our equation. So again, to balance it out, we've got IO3 with a negative charge plus 6 hydrogen plus 5 electrons, yielding iodine and water. Now, we're not done, because what we have to do is we have to balance everything else out in this reaction. Okay? And how do we do that? Well, we're going to multiply everything by 2. And why? Because iodine is not balanced. Look, we have 2 iodines on the right-hand side, and we only have 1 iodine on the left side. So we have to balance that one out. And now, when we do that, we're going to put a 2 right there to balance out our iodines. So now we have 2 IO3, the negative charge, plus 12 hydrogens, plus 10 electrons, producing I2 solid plus 6 H2Os, liquids. The key, the -1 comes from the iodate. The iodate is a polyatomic ion for iodate. So there's a negative charge on that. Just like if I were to write out the sulfate ion of SO4 with a -2 charge, where iodate also has a negative charge, and it's -1. Okay. I'm glad you asked that, Mika and Lainey. I'm glad y'all asked that. Yes. And Matt from Earth, you can always go back and look at this video on my YouTube channel. So if you are, if you need to go back and replay this, it's on my YouTube channel. So you can take notes from there. Okay, I knew y'all were going to ask, where did that 2 go? Let me show y'all. I'm so glad y'all asked that. So let me show you. Okay, if I were to put a 2 right there, what's 2? Okay, you would end up with 4 iodines right here. Okay, you see this right here? That 2 times that 2 will give you 4 iodines. And that's not what you want. So again, if I put the 2, okay, right here, if this 2 right here, let me highlight it for y'all so you can see. If I take that 2, and yes, I multiplied it by everything that was in parentheses, by putting the 2 here would cancel it out, and you would end up being left with just 1 iodine, okay? All right. Hey, Aaron. Good job, Ray. I'm so glad. I know, Desi. Did that help you guys with me explaining that part? If I need to do it again, tell me. Say, run that back. If you think I need to say it again, run that back. So again, let me show you all so that way you can see it, okay? If I take this 2 right here, right now I have a subscript of 2. If I multiply that by 2, that 2 tells this 2 right here, this 2 tells this 2 that you're going to have 4 iodines. But in order to take care of this iodine here that I'm going to highlight in pink, in order to take care of this iodine, remember initially it was only 1 of them, but we needed 2 of them. So I have to multiply the entire formula or the entire chemical reaction by 2. And in order to do so, I'm going to multiply the 2 by the first formula, the 2 by the 6 hydrogens, the 2 by the 5 electrons. And then when I multiply the 2 times iodine, okay, right there, that's going to end up giving us 4, and we don't want that. So the 2 is understood in that regard. The 2 is understood in that regard. Okay, yes, yes. You're welcome, honey. You're welcome. All right. Y'all ready for another one? Just to make sure you guys got it. I did not have the opportunity to do one with basic solutions. So I'm going to have to, of course, come back and do this one, and I may have to make a separate video on basic solutions. But with this one, all right, Bree. If you think about acidic solutions, again, all you have to do is remember to balance the side that does not have oxygen attached. And when you do that, that's then going to flip the other side to balance the hydrogens also. Okay? That's what it's going to end up doing. Let me see if I can do one for basic. Let me see. I'm going to flip through. Let me see if I can do one for basic. See, and these problems take so long to do. That's the only problem. Yeah, the AP chemistry is basically a first year of general chemistry 1 and general chemistry 2. Honors chemistry is just regular high school chemistry, but your teachers may give you more practice problems to do. They may give you more challenge problems to do. Where, like, for instance, if I tell you to go from let's say 4 grams of water to, let's say, 5 grams of oxygen, your regular class may say 4 grams of water to moles of water or of oxygen. So things are more at an accelerated pace for honors chemistry than they are for regular chemistry. Yes, Ray, this is dichromate. Go ahead, sis. You got that. You know the name. I'm glad you're doing something. What is your major? What is your major? So yes, let's do that, doc. Oh, girl, you good. You are good. Okay, you said you wanted the dichromate one. Let's see. I was trying to do a basic solution for y'all, but yes, this is still in acidic solution. So what I would do, I'll do a basic solution. I'll just have to come back online to do it. And she said, yes, the one right there. Okay, I got you. Okay, so because I know I'm going to need all this space, let me go ahead and scroll this down to its own page. Okay, again, guys, this one is in acidic solution. Okay, so because I'm telling you all that this is in acidic solution, step 1. So I'm going to actually make you, we're going to do baby steps with this one, okay? The baby steps, we're going to first take the iodine, okay? And write it out like this. We're basically separating each of them into their respective oxidation reduction processes, okay? And then the second equation, we've got Cr2O7 with a 2 negative charge, AQ, yielding Cr with a 3 plus, AQ. Okay, now, when you do this, you want to balance out your iodine, okay, because that's not balanced, and you want to balance out your chromates also, all right? So for this first one, I'm going to do this first. If there's only 1 iodine on the left, but we've got 2 on the right, we're going to multiply this one by 2. So we end up with writing this one out as being 2I with a negative charge, AQ, yielding. Remember, the 2 does not, it gets multiplied, but if you multiply the 2 times that subscript of 2, it's going to end up giving you 4, and you're going to be doing this all day. So instead, it's almost like you're flipping it, okay? It's almost like this, guys, 2 over 1 times 1 over 2, okay? It's essentially kind of similar to something like that. All right. But because you want to keep the 2's, together in terms of the subscript, you're going to leave that one with I2. Okay. So they're equal. 2I is the same thing as I with the subscript of 2. Now, this next one, we've got 2 chromates on the left, but we only have 1 on the right. Yes, that's correct, Ray. Yes. Because we have 2 chromates on the left, but we've got 1 on the right, what we're going to do, we're going to do what? We're going to multiply that times 2 also to balance it out, okay? So again, when we do that, it's essentially like you're saying 2Cr2O7 with a negative 2, giving us 2Cr with the 3 plus charge, okay? I just wanted to put that out there so you all would know where these numbers are coming from, okay? Now, you have to balance the oxygens because remember, the chromate side is good, but the Cr side is not good, all right? So we're going to have to add water to that side to balance it out. But let me show you this, though, okay? Let me show you this. I'm going to write out this reaction here, the 2I, okay, plus the Cr2O7 with the 2 negative, producing the I2 plus the 2Cr with the 3 plus charge, okay? So I just pretty much rewrote this reaction here, okay? I just pretty much took everything down and rewrote it out, okay, in its proper form, okay? Now, Fatima, the 2 doesn't get distributed because if you multiply that 2 times this formula right here, that 2 is going to cross out or cancel out. Okay, so that's why we did not want to distribute the 2 to that. We're trying to balance the chromate and make it match the other side. So that's what we're doing. We're trying to balance the chromate to make it match to both sides. So now, what we're going to do, we've got to add water to this side over here, okay? We've got to add water to the right-hand side, okay? Because that's the side that needs oxygen. So we're going to balance. We're going to put H2O. Oops, sorry, y'all couldn't see that, okay? You're going to add water to that side over here, H2O. And now, remember, we have 7 oxygens right here on the left side. Because we have 7 on the left side, you know what we're going to have to do? We're going to put a 7 right here in front of H2O, okay? So I'm going to put it in red so you all can see that. I put the 7 right there for H2O, okay? The 7 goes there. And now, how many hydrogens do we have? We have 14. So guess what we're going to have to do over here on this side? We're going to have to add 14 hydrogens to this side, okay? 14 hydrogens. So y'all see I write so big and everything just kind of merges together. But I'm going to rewrite this formula out so you all can see that, okay? It was 2 iodines, AQ, plus Cr2O7 with a 2 negative charge, AQ, plus 14 hydrogens. And now I'm going to leave a space because we're going to have to determine how many electrons we're going to need, okay? So I'm going to put a plus sign here, leave that space right there. Yields iodine over here on this side, solid, plus 2 chromates, the 3 plus charge, aqueous, plus 7 H2Os, liquids. Now, what are we going to have to do for this next part? We're going to have to determine the number of electrons we need, okay? We have to determine the number of electrons that we need in order to balance it out. So now, for this side over here, okay, you notice that your chromate had 6, because look, that 2 right there times that 3 plus charge gave us 6. So we're going to have to get rid of that, or by balancing the sides out, okay? And that's going to give us those 6 electrons right there. So remember when I said we was going to have a gap or a space? That's what we're talking about right there. Okay, same thing over here. There's a gap. So to get rid of those electrons that I highlighted in pink, I'm going to have to put 6 electrons right here. And to get rid of these iodine charge right here, guys, we're going to have to add 2 electrons to that side. And y'all, again, this is why I said before, it takes a lot of space to do this. And because of my big handwriting, it kind of makes everything look so jumbled up. But what are we going to have to do now in order to make sure that this reaction is complete? Because these electrons aren't balanced. We have to now balance this one that I'm going to highlight in blue. We have to balance this one by multiplying the entire thing by 3. Okay, we got to multiply that whole thing by 3. Thank you, Adam. I've got some thermodynamic equations on my YouTube channel and on my TikTok page. So go check it out, okay? But thank you so much for your kind words. Yes, thank you, Raquel. Why 3, Evie? Because there are 6 electrons on this side, the one that I'm highlighting in blue. There are 6 on that side, and we got to cancel those out. So we have to multiply only this reaction that I highlighted in blue. We've got to multiply it times 3. So I'm going to put a big 3 in front of that. Okay? Thank you, Ray. So in order to do that, and y'all, I'm gonna clean this up and go through it again without all the extra talking that I'm doing now, and I'll repost this particular one again without all the extra, talking that I'm doing, and make it look a little cleaner. Okay. So I'm going to multiply the 3. That's going to give me 6 iodines right here, aqueous, plus. Now what? What are we going to do? That was only for the iodine, y'all, okay? That was only for the iodine that we had to multiply that one, okay? The one that you're trying to get rid of, that's the one that you're fooling with in terms of the coefficient in front. All right? Plus 14 hydrogens plus 6 electrons. So basically, and you know what I should have done to make it easier? I should have just only concerned myself with the iodine up here from before. But again, like I said, I'm going to fix this up so that it doesn't look too bad. So yes, we're multiplying, no problem, Ray. It's okay, honey. We're multiplying it by 3 to get rid of our 6 electrons to balance them out. Because on the right-hand side, there were 6 additional electrons, and on the left side, there were only 2. Okay, so now what I'm going to have to do is write out the rest of this equation. But again, I only multiply the 3 times the iodine coefficient and times the 2 electrons. Now I've got my iodine here. And that's going to also do what? That 3 has to go over to that iodine to make sure that we have our 6, okay, that we need. All right. So now that's the next part. Let me highlight that in yellow so you all can see that. You only do one thing at a time, okay? One thing at a time. So now that 3 that we used before, You're going to multiply it now times the second equation, okay? So that 3 gets distributed to that one. So now, when you do that, that's going to take care of your iodines, because remember, they have to be equal. We have 6 on the left. We got to have 6 on the right. And y'all, these physical states are cramming up and making it look sloppy. Okay, so yeah. And then I'm going to put the 2 chromates here with the 3+ charge, plus my waters and the 6 electrons. Woo! Good gracious. My goodness. Now, we did all that work just to say we're going to cancel the hydrogens out, okay? We did all of that to say let's cancel those hydrogens out. So now write what you have left over, okay? Write what you have left over. We've got 6 iodines plus your chromates plus your hydrogens, producing your 3 iodines plus your chromates again, plus your water. And I know I left some of those physical states off, in some of the equations, some parts of the equations, but in the final result, this is what you end up with. I'm going to zoom in a little so y'all can see that. And as we say, we can now drop the mic. But in this case, we drop the stylo pen. And we are done with that problem. So I'm going to let that breathe for a second. Sorry, y'all got to give me a drink. So why didn't the dichromate or hydrogen get multiplied by 3? Okay, very good question. So whatever you're trying to balance out, that's the one that you want to take care of. And what I should have done so that it wouldn't look so sloppy and messy, because this looks like a hot mess. Okay, I'm just saying. Woo, this looks so and that's what happens. Things get lost in the sauce when you look at it this way. But again, we had to do that in order for you to take care of your iodines and your electrons. And remember, we already did it for chromate. See the 6 electrons here? That's the one we dealt with first. I know, Kay, I do too. That's why I said I'm going to redo this again, because it is a lot going on this screen. I know. I know. Chemistry is like that. Math is like that. We took care of the electrons first for chromates. See, because we had 6 over here on this side, and therefore we had to put 6 over here on the right-hand side. Therefore, we had to do it on the left side. And that resulted in all of this mess right here. It's like, what we call it, organized chaos. Okay. So let's see, JXZY said, how do we know which one to take electrons from before multiplying by 3? It's the chromates that you're concerned about. You're looking at your chromates. If we go back up here, okay, what I initially started out with right here, the chromates weren't properly balanced. We ended up with 6 on this side. So that ended up resulting in us having to deduct those at the end down here in this greenish bluish color. But what I'm going to do, I'm going to do a voiceover. I'm going to redo this particular problem so that it's a lot fresher and better looking, okay? Because I know this looks so sloppy. All right. Right, well, yeah, that's right. That's essentially what, right. Only use it for electrons. Yes, that is correct. You only use it for electrons. Yes. So like when we go up here to the basic one, okay? When we did this easy peasy one, this one was easy because we had to first figure out, you're welcome, honey, you're welcome. We had to figure out how to make our iodines balance because they were okay on this other side. So that's what's happening here. You've got a lot of extra stuff going on because of those chromates, and those chromates had oxygens, and the iodine needed to be taken care of. So it just made everything seem so complicated. Oh, thank you. You're okay. Thank you, Scotty. That's right. JXZYYY. That is correct. That is correct. So although this looks like a hot chemistry mess, a hot chemical mess, I'm gonna fix this up, y'all, so that I can make it right. Because whenever I'm tutoring like online like this right now, live, I'm addressing y'all's questions, and so I'm having to highlight certain things and make things look different. As a result of that, you got all these different colors going on. Oh, thank you. Thank you, thank you, thank you. So yes, guys, I will repost this in a cleaner version. But in the meantime, and in between time, make sure you guys come out to my YouTube channel, so y'all can get that as well. You all can get more tutoring that well too. And make sure that you all subscribe to the channel so that you all can see all of these problems done, in a different way. So I'm going to actually clean these problems up so that you all don't have to see all this extra messiness, okay? So if you all have any other questions, let me know. Put them in my last video. Just go back through and say, all right, next week, can you do a lesson on whatever? Okay, I know many of you all are getting prepared to end the semester. So I want to make sure that if you all need extra help on something, let me know. You're welcome, Ray. I appreciate you for asking these wonderful questions. Those were fantastic, and I really appreciated your input. And all of you guys that came on board, if you were new to me, welcome, welcome, welcome to Professor TK the Chemist Lunchtime Chemistry Tutoring Day. We do this office hours Monday through Thursday. Yes, thank you, thank you, thank you. I appreciate you as well. So make sure y'all don't forget to tell a friend, to tell a friend, to tell a friend. Okay. All right, guys. Y'all have a great rest of your day. A beautiful day. Get you some sunshine. Activate that vitamin D, that melanin, and make sure y'all stay hydrated. I'm getting ready to take care of my throat chakra. Okay. Y'all take care. Peace.